Beneath the shadow of Mount Vesuvius, buried under layers of volcanic debris, there is a library that should not have survived at all. Nearly 2,000 years ago, the eruption that destroyed Pompeii and Herculaneum turned hundreds of papyrus scrolls into blackened, brittle objects that looked more like lumps of charcoal than books. The words were still inside them. But there was a problem. The scrolls had been carbonized so completely that trying to open them could destroy the very text scholars were trying to save. For centuries, researchers faced an impossible choice: read the scrolls and risk destroying them, or preserve them forever without ever knowing what they said. Then, in 2026, scientists did something that once sounded like science fiction. Using powerful X-rays, three-dimensional imaging, machine learning, and a technique known as virtual unwrapping, they reconstructed one of these sealed scrolls digitally, layer by layer, and for the first time, they were able to follow its writing from beginning to end. The scroll was Ph. Archie, 1667. Its text had been silent since the eruption of Mount Vesuvius in AD 79. Now, after almost 2,000 years, that voice has finally returned. To understand why this discovery is so extraordinary, we have to go back to the final days of an ancient Roman town. Herculaneum sat on the Bay of Naples, only a few miles from Mount Vesuvius. Unlike Pompeii, which was buried primarily under falling ash and pumice, Herculaneum was overwhelmed by extremely hot volcanic material. The eruption struck in AD 79, burying the town and everything inside it beneath massive layers of volcanic debris. Among the things preserved was an extraordinary collection of books at a luxurious villa, later known as the Villa of the Papyri. Archaeologists eventually discovered hundreds of carbonized papyrus scrolls. The collection is considered the only known surviving large-scale library from Greco-Roman antiquity. And yet, this incredible preservation came with a cruel consequence. The books had survived, but they had become almost impossible to read. The scrolls were no longer soft sheets of papyrus. They had been transformed into fragile, compressed masses of carbon. Imagine taking a perfectly intact book, setting it on fire, rolling it tightly while it is still burning, and then somehow preserving the resulting blackened cylinder for 2,000 years. That is roughly the problem archaeologists inherited. The individual layers of papyrus were still there. The writing was still there, but the entire object had become so fragile that physically separating those layers could destroy them. And for centuries, scholars tried anyway. The Villa of the Papyri was excavated in the 18th century, beginning in the 1750s, and almost immediately, researchers began experimenting with ways to open the mysterious scrolls. Some attempts were remarkably destructive. Mercury was used, chemicals were applied, papyrus sap, ether, gelatin, and acids were among the substances tried in various efforts to soften or separate the carbonized layers. Some scrolls yielded fragments of text. Others were damaged or destroyed. The more researchers tried to recover the writing, the more obvious the terrible trade-off became. The only way to read some scrolls could also be the way they were destroyed. And yet, what little scholars managed to recover revealed something astonishing. Many of the texts were written in Greek and were associated with the Epicurean philosopher Philodemus, whose works occupied a major part of the library. These weren't meaningless records. They were philosophical texts, arguments, ideas, discussions about morality, religion, pleasure, politics, and the nature of the gods. A buried library from the ancient world was sitting in front of modern scholars, but most of it remained locked inside blackened cylinders. More than 600 unopened scrolls still remain, according to the Vesuvius Challenge's current research reporting, and those are just the ones already known. Large parts of the ancient villa and surrounding site remain unexplored, meaning there could potentially be even more waiting beneath the ground. For a long time, there appeared to be no way around the problem. Then a completely different field entered the story: computer science. In the early 2000s, University of Kentucky computer scientist Brent Seals began developing a radically different idea. What if the scroll didn't have to be opened at all? What if scientists could somehow see inside it? The concept sounds simple. The execution was anything but. Instead of physically separating the layers, researchers could scan the entire scroll using X-rays and create a three-dimensional map of its internal structure. A hospital CT scanner can reconstruct the inside of a human body. The idea here was similar. Except instead of scanning a body, researchers were scanning an ancient book that had been crushed and carbonized by a volcanic eruption almost 2,000 years earlier. But there was a fundamental problem. Seeing the layers wasn't enough. Researchers had to figure out which parts of those layers were actually writing. And this was extraordinarily difficult because the papyrus and the ink had both become carbonized. In many conventional X-ray scans, the ink did not stand out like dark letters on white paper. The signal could be frustratingly subtle. The researchers needed a way to teach computers what ancient writing looked like inside these distorted, rolled, carbonized layers. So they began developing increasingly sophisticated computer vision and machine learning techniques. The goal was not for AI to simply look at a picture and magically recognize Greek. The real challenge came earlier. The computer needed to determine where the papyrus surface was, separate that tangled surface from surrounding material, flatten it digitally, and identify microscopic patterns associated with ink. It was less like reading a photograph and more like reconstructing a shredded book from a three-dimensional maze. Then came another breakthrough. The scans needed to become dramatically more detailed. Researchers began using synchrotron facilities, enormous particle accelerator-based X-ray sources capable of producing extraordinarily intense and precise beams. Some scans reached resolutions down to around 2 microns. That is only a tiny fraction of the width of a human hair. At this scale, researchers could begin seeing details in the papyrus structure that ordinary imaging could not resolve. The scroll was no longer just a black cylinder. Inside the digital volume was a three-dimensional landscape of fibers, folds, layers, and distortions. And somewhere inside that landscape were letters written by a person who had been dead for nearly 2,000 years. But there was still one enormous obstacle. The scroll was rolled. Imagine taking one long sheet of paper and wrapping it around itself hundreds of times. Now imagine crushing that roll with extreme heat until the layers deform, collapse, and stick together. If researchers tried to simply flatten the scan, they would tear the digital reconstruction apart. The software had to follow the actual path of the papyrus, layer after layer, turn after turn. The team effectively needed to reconstruct the geometry of a document that no human could safely unfold. This process became known as virtual unwrapping. The scroll would remain physically sealed on a table, but inside the computer it could finally be opened. And then came the part that truly required artificial intelligence. Researchers trained machine learning systems to detect the subtle signatures of ink. One approach became known as an AI ink detector, or ink hound. The system wasn't simply guessing what an ancient author had written. It was searching the three-dimensional data for physical evidence that writing had once been placed on the papyrus, subtle changes in surface texture, tiny morphological patterns, force that human eyes would struggle to recognize in the raw scan. Once detected, those signals could be projected onto a digitally flattened sheet. For the first time, researchers could begin seeing something that resembled actual writing. Ancient Greek letters emerging from a piece of charcoal that had been considered unreadable. In 2023, the researchers took an extraordinary step. Instead of keeping the technology inside a single laboratory, they released scans and code to the public and launched the Vesuvius Challenge. It turned the problem into an international competition. Computer scientists, machine learning researchers, classicists, papyrologists, and volunteers around the world could work with the same data. The first major prize was won after competitors successfully recovered previously inaccessible letters from the scrolls. That achievement proved something that had once seemed impossible. The writing really could be detected without physically opening the scroll. But it was still only the beginning. Reading a few letters was one thing. Reading an entire ancient book was another. For years, progress came in fragments. A few columns here, some letters there. Pieces of ancient Greek emerging from layers that had been sealed since the Roman Empire. In 2025, researchers working with one of the Bodleian Library's Herculaneum scrolls produced an image revealing part of its hidden interior and several columns of text. It was a major achievement, but even then, the scroll wasn't completely readable. Researchers were still trying to improve the software, still trying to understand the distorted layers, still trying to separate writing from the confusing textures of carbonized papyrus. Then came 2026, and this time something changed. Researchers working with the Vesuvius Challenge announced that Herculaneum 1667 had been virtually unwrapped and read from beginning to end. For the first time, an entire Herculaneum scroll had been digitally opened without physically opening it. The scan and computational pipeline allowed researchers to reconstruct its writing across roughly 1.5 meters of readable text, spanning around 20 columns. And what they found inside was not a shopping list, not a routine administrative document, not a forgotten personal letter. It was philosophy. The text appears to be a previously unknown philosophical work focused on questions surrounding ethics, human nature, and moral progress. And there was another surprise. The handwriting appears significantly older than that of many other Herculaneum scrolls. Papyrologist Federica Nicolardi has dated the writing to the 2nd or possibly 3rd century BC, potentially making it centuries older than the destruction of Herculaneum itself, and among the oldest scrolls in the collection. That means the people who wrote this text were discussing questions of morality generations before the Roman Empire reached its familiar peak. The volcanic eruption didn't create the mystery, it preserved it. But Peach, 1667 was not the only revelation. Another scroll, P-Erch, 139, produced title and author evidence identifying it as On God's Book 8 by Philodemus. That number may sound insignificant, it isn't. Before this discovery, scholars had known about earlier books in Philodemus On God's series. But Book 8 adds evidence that the work extended much further than previously established. In other words, the scroll didn't simply give historians another ancient text. It potentially revealed the existence of additional lost books that scholars didn't know were part of the series. And somewhere in the remaining collection, more of them could still be waiting. But there was still one question: how can a computer possibly know that what it sees is real writing? After all, ancient papyrus is damaged. The layers are warped, the letters can be incomplete, and an algorithm could potentially mistake a random fiber or crack for an ancient character. This is why the breakthrough wasn't simply an AI demonstration. The final stage involves human specialists. Papyrologists study the reconstructed Greek. They compare the letter forms. They examine words and grammar. They determine whether fragments belong together. They test whether the recovered text makes linguistic and historical sense. The machine helps uncover the physical evidence. Humans then interpret what that evidence means. It is not AI replacing historians. It is something much more interesting, allowing historians to see what they could never physically reach. And that distinction matters. Because the most incredible part of this story isn't that an artificial intelligence suddenly became capable of understanding a 2,000-year-old book. The AI didn't travel back to ancient Rome. It didn't somehow know what the philosopher intended to say. It didn't open the scroll. The physical scroll is still sealed. What changed was our ability to extract information from it. X-rays created the three-dimensional evidence. Computational geometry reconstructed the twisted papyrus. Machine learning helped identify the ink. And papyrologists turned those pixels into words. It took physics, computer science, mathematics, machine learning, and classical scholarship, working together to accomplish what centuries of brute force methods could not. For nearly 2,000 years, these scrolls were trapped by a bizarre paradox. The eruption destroyed the civilization around them, but preserved their books. The heat turned the papyrus into charcoal, but that charcoal protected the writing. And then time made the scrolls too fragile to open. For centuries, preservation and discovery stood on opposite sides of the same problem. If you protected the scroll, you couldn't read it. If you opened it, you might destroy it. Now that equation has changed. The scroll can remain sealed, and the words can still come out. That may be the greatest significance of the entire discovery. And there are still hundreds of unopened scrolls. More than 600 remain according to Reuters' June 2026 reporting. Only a fraction of the known collection has been fully investigated with these new techniques. Researchers have already scanned dozens of scrolls and fragments, while improved algorithms are making the process faster. The Vesuvius Challenge has awarded more than $1. $8 million in prizes for work on the problem, and is continuing to encourage researchers to improve the technology. The goal is no longer simply to prove that one scroll can be read. The goal is much bigger. Read the library. Imagine what could still be inside: lost philosophical works, unhunal histories, poetry that disappeared from the ancient world, arguments between schools of thought that historians know only from fragments. Books whose titles have survived in ancient references, while their actual pages vanished centuries ago. And perhaps texts written by authors whose names have completely disappeared from history. For centuries, scholars searched museums, ruins, and libraries for fragments of the ancient world. Now they may have to look somewhere else, inside objects that have been sitting in front of them for 275 years. Objects they already knew contained books, but could never safely open. So what really happened to the scroll that was thought to be lost forever? It wasn't lost. It was never truly gone. It had been sitting in the dark all along. The words survived the eruption of Mount Vesuvius. They survived nearly 2,000 years of burial. They survived centuries of failed attempts to open them. They survived the destruction of their original world. And finally, they survived us. Because in the end, the solution wasn't to break the scroll open. It was to look inside without touching it. A Roman author wrote those words thousands of years ago, never imagining that the next people to read them would live in a world of particle accelerators, machine learning, and three-dimensional computer models. And perhaps the most extraordinary part is that this may not be the final chapter. It may be the first page of an entirely new library. A library that was buried by a volcano almost 2,000 years ago, and is only now beginning to speak. Thanks for watching. If you enjoy historical mysteries uncovered through science, technology, and archaeology, make sure to like this video and subscribe for more discoveries from the hidden pages of history, because sometimes the greatest mysteries aren't buried without a trace. They're buried with the evidence still inside.